Yeah, in this example, police car is located 30 feet to the side of a straight road. So that means this must be 30, right? That's how far the police car is from the road. A red car is driving along the road in the direction of the police car and is 100 feet up the road from the police car. So this must be 100 from there to there, right? Up the road from the police car. Police radar reads the distance between the police car and the red car is decreasing at a rate of 80 feet per second. How fast is the red car actually traveling on the road? Okay. You know, step one, find or identify the rate letters. So what are all the rates in this problem that they speak of? Let's read through it again. Cars located, rates yet. Red car is driving along the road in the direction of the police car and it's 100 feet. Those aren't any rates. The police radar reads the distance between the police car and the red car is decreasing at a rate, 80 feet per second. So this is what? This is the distance from the police car and the red car. That's this right here. This is the distance, right? Because if this is the police car right here, and this is the red car, the distance between them is always a straight line, right? The distance between 2 points is a straight line. So that is the distance between them. And they're telling us that dz dt, what they say, decreasing at 80 feet per second. So that's negative 80 because it's decreasing, right? That distance z as the car goes down here, that, and z is z, wherever the car's at, say the car, once it gets to here, then the triangle will be like this, and this will be z. Z's got smaller. See that? Z is the distance from the car to the police car, from the red car to the police car. And that Z is getting smaller. It's going down by 80 feet every second. So things that are getting smaller. So the length of side Z of that triangle is shrinking as the car goes up the road and gets closer to the police car. This distance from the red car to the police car, Z, is shrinking, decreasing, going down by 80 feet every second. And here comes the other way. How fast is the red car traveling on the road? So in other words, they're asking us, what is dy dt actual? Right? Because this is a y, which is the distance, from where the police car is at on the highway to the red car. And they're saying, how fast is the red car traveling the road? How fast y is changing? Y is the distance the red car is traveling. And so we want to know how fast that is. So there's my two rates, the only ones they mention. Find an equation relating, right? Related rates, relating those letters only. You can have numbers, but no other letters. In this case, Z and Y. We want some kind of equation relating Z and Y only. Only. Well, it's pretty obvious, right? It's a right triangle right here, right? It's a little right angle. So, a squared plus b squared is c squared kind of thing. A squared plus b squared is c squared. Which one's a, b, and c? Well, remember, the c has to be the one across from the right angle. This is the c. So it's going to be the z. The other two sides are y. Y, it doesn't matter what you call those, and then what? 30. Now, you might wonder, the good question would be, Mr. Why didn't you put in the 100 here? Right? You put in the 30, you didn't put in the 100. Well, whenever it has a letter, you want to use the letter. We don't want to plug in any numbers to the end. Remember, that's step four. Now you might say, yeah, but you put in a 30 right there. Well, that's just always 30. That's not changing, right? The police car is not getting closer to the road or further from it. That 30 is just fixed. Whereas this Y is changing as the red car moves closer. This Y is getting smaller and smaller and smaller. The Z is getting smaller as well. And plus, we want a relationship between Y and Z. So, of course, I need Y and Z. So you cannot plug, when I say plug in the numbers at the end, I mean the numbers that are changing. The 100 is changing. The 30 is not. So the 30 is fine right now. He's never changing. But the 100 is. So we can't plug him in into the end. right? Because you can't, yeah. So let's just move on. So there's that. And step three, d dt on both sides. So I'm going to go k to k. So let me go d dt of y squared plus 30 squared. And I'm going to go d dt of z squared. All right, let's take some derivatives. Bring that 2 down. Y, lower the power by 1 times dy dt. Remember the chain rule. Chain rule says bring down the power, lower by 1, and then derivative of the inside function, dy dt. Plus, same thing here, bring down to, no, that's just a number, 0. All right, derivative of numbers is 0. And here, bring down the 2. Z, lower the power by 1 times dz dt. Well, that's a nice little equation. And now, step 4 says plug in the numbers. And by the numbers, I should say the numbers that are changing. So you can't plug in numbers that are changing beforehand because they're changing, right? You can't plug them in until afterwards, after you've done the derivative. Because you take the derivative of a constant number, it just goes to 0. We needed a y there. Y is changing. So now we can plug, okay, y is 100. What do we need here? We got y is 100, dy dt, and z. Do we know? Oh, there's dz dt. We want dy dt. Okay, and then what else do we need? Z? Guess we can get z. Okay. Oh, is that the one we need? So we need y, z, dy dt. We got the 2. We need 1, got the other. And we got y. So what we need is z. Z is a problem. Oh, right there. So that's it. So z, we get z. Let's get z real quick. So grab that equation right here. So we get y squared plus 30 squared is z squared. And then remember, now we can plug in 100 for that y because y is 100. We just couldn't put it in before the derivative because y is changing. But now we've already done the derivative. Rates of change are done. Plug in y is 100. Totally fine to plug in now. And so that's going to be whatever number that is. Isn't that 10,000 and then 30 squared is, it's 19, to come up to be 19,000. And then we're going to root both sides of this thing, right? Root, root, plain old z. I think, I hope I did that right. Oops, didn't do that right, huh? Let me see. Yeah, what is it? 30 times 30 is 9. Oh no, 900. I blew that. Only 900. So this is 100, add two zeros. Yeah, it's 10,000. So it's 10,900. There we go. 10,900. You use decimals. I'm just trying to go quick here. So 10,000 and then 30 times 3 is 900. Yeah, 10,900. Okay. So anyway, so z squared of that. So we got z. So here we go. So we got 2 times y. We knew y. Y is 100. Now we can plug that in because the derivative is over. 2 times 100. dy dt, do we know that one? Oh, we're looking for dy dt. We know dz dt is negative 80. So we're looking for dy dt equals, zeros out of there, 2. And then z is this square root we just found, 10,900. dz dt, and dz dt is up here. It's a negative 80. dz dt, negative 80. Okay, want to solve for dy dt. So divide both sides by 2 times 100. Boom, 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 boom. 2 times 100. Hey, these cancel. So there we go. So dy dt equals, and then I'm going to type this into Desmos. Square root of 10,900. Let's go to Desmos. 1,900. Forget the rest. Square root of 10,900 times negative 80 over 100 times negative 80 over 100 times negative 80 over 100. There we go, negative 83.522. So negative 83.522. Negative 83, scribbly, 522, 522. Now, it's negative. Why is it negative? Because it's decreasing, as we said. Why is the length from there to there as the car goes down the road? Why is decreasing? But notice what they said. The red car's actual speed, give a positive answer only. So yeah, y is shrinking, so it's negative rate of change, but they want us to just give the speed of the car as a positive answer only. So 83.522, just give it positive. 83.522, that's what we got. And so there we go.